Hello, I'd like to just give like a little bit of a visual description of one of the tests here. Just as a very hard to explain within text, and obviously it's very easy for me to have just came up with a factorization with that certain amount of factorizations. I'm just going to give this a random string. For example, this is not Linden string. I can even just jumble up some letters in there as well, just to make it a little bit longer, add some complexity into it, just so we've got some more letters. And I basically just like to explain how this optimization type here, optimization type 3, which is the K input, how it actually works. Because trying to explain this in the context of a paper, or if I didn't have visual aid, is extremely hard. So, for example, if I was to want, for example, let's say 4 factors at the moment, it should take into consideration this string under the assumption here that we want the optimization type 3, which is where we're searching for a specific amount of factors. And if I press run, it should have popped up here with hopefully the right amount of factors. Yes, see how we wanted 4 and it's came up with 4. And similarly, I can just I'll change up the string a little bit more. For example, add some more things in. For example, say give it let's say 14 factors this time. Let's go a little bit higher. I can press run there, and for example, it's returned us with the alphabet ordering here with 14 factors. That's just to show how effective this is actually working, but it's just because it's really hard to explain in text, and this is why I've made this backup video that I'm just going to link in with a short bit on the appendix of the report, just to show that it's actually clarifying working. And I might give one more example. So if we went over to the code, sorry, it's all the way over here. Maybe give it a bit more letters. Maybe even some numbers as well. Just give the idea of the sort of complexity we'll be dealing with here, because now we could be dealing with multiple, even more than 20, 30 characters. Just to show you that the algorithm itself is actually quite robust to the size of the search space. The size of the search space doesn't really have that much of an effect on it. I'm just going to move this over here so I can actually press the button. Oh yeah, no, I forgot to say this thing for random number. Let's say we want 4 factors. Press run. Ooh, I've got a problem. That's because I haven't put an equal sign. If I press run here, so in the output, it gave us it's very long because of the size of the alphabet ordering that we actually used, but it still managed to give us 4 factors. And simply as a small one, for example, like hello, my name is Thomas Mills, and let's say, for example, we want to factorize that into something. Let's say we want to factorize it into something that it clearly can't factorize. I'll first just try and see if it can factorize into 1. Don't think it can because it's got some exponents of characters within there. But it'll get as close to it as possible if it can't. Oh no, yes, it could actually factor into a 1 there. I'll try a 2. Yes, and now we can see split it up into 2 factors. And similarly, I could type in something like 6. Yep, and as you can see here, it's found a factorization with 6 factors. And it's basically this video is just the purpose of me being able to explain it visually, because obviously I could just put any old factors on there and said that's what I wanted. But hopefully I'm going to include this in the report, and hopefully it should get me some extra credit. Thanks very much for watching if you're interested.